So we're going to be talking about for the next hour or so, kind of an introduction to Metasploit, what it is, how it works, why you should use it. Um, the goal here is to kind of give you a kind of a bird's eye view of Metasploit, either from somebody that has heard of it and doesn't know what it is, or maybe somebody that's poked around a little bit, but had a hard time getting started with it. So hopefully by the end of this webinar, you'll feel comfortable jumping in, kind of learning how to use it and doing a few exploits and playing with stuff and hopefully you'll be able to find a way that you can use this in your regular daily work. So I'm going to go ahead and jump on in here. As you may notice, if you know Kevin Johnson, I am not Kevin Johnson. This is not his voice. The problem with having one go to training license is that his name gets on the attendee list. But now my slides are not progressing. How does that work? There we go. My name is Nathan Sweaney. I'm a senior security consultant with Secure Ideas. I've been here for about a year or so. Prior to that, I spent about 8 years in the point of sale industry, dealing with PCI and retail, grocery, that kind of stuff. And quite honestly, just got tired of trying to secure those pieces of those point of sale systems. I am based in Tulsa, Oklahoma. Secure Ideas, we are spread across the country. We've got offices and we actually have a new office. We have 3 consultants in Jacksonville, Florida. And as of this morning, we officially have an office. Those guys aren't working out of their homes anymore, so that's exciting. We also have an office in Denver with several people. And then we have some consultants spread around. I'm in Tulsa. We've got a guy in Salt Lake City and one in North Carolina, I believe. And there's a picture of me there just so you have an idea what I look like as I'm talking. So you can picture those are 3 kids in central Guatemala that I had a chance to spend with some time with about a month ago. So Metasploit, let's get to talking about it. I'm just going to jump in. If I start talking too quickly, say something, tell me to slow down, tell me to repeat, whatever. Sometimes I get excited and just start talking. So in the good old days, in the 90s, early 2000s, we had exploits. There have always been exploits, right? People started finding problems with applications and they started writing proof of concepts and putting out exploits to use to compromise systems. Sometimes they were malicious attackers putting the stuff out there saying, hey, look what I can do. You know, there's a lot of bragging and ego back in those days. Not that there isn't today still. But what was common was people would just create an exploit, they would throw it out there, and that was it. There was a lot of problems with being able to reuse those exploits in some type of professional manner. There was no consistent form, no standards, no standard language. You'd have proof of concepts written for a specific use case. So I found a vulnerability in this version of this software on this operating system that I happen to have, and I wrote my exploit to work in that specific case. Well, that's great for me, but that doesn't help you who has a slightly different operating system, or maybe a slightly older version of the system, or maybe I write mine to the payload of my exploit does some specific command that I needed, and you want it to do something else. So it was a lot of hassle dealing with having to manage those back then. You also had people would write an exploit and then they would either keep it themselves in kind of their own private collection, or maybe they would send it out to their friends, or possibly they would, publish it on a mailing list like BugTrack or something. What ended up happening is, there's no central location that you can go get exploits. You also had kind of questionable sources of, okay, who actually wrote this and what does it really do? If I'm not a assembly guru, my forte is C, and I'm trying to read through this exploit and figure out what it does because it's written in assembly, that may be difficult for me. Or vice versa, maybe it's written in some language that I've never seen, and now I got to go spend time trying to figure out what it does and then how to modify it so that I can use it in my specific cases. All of this was great for malicious attackers. If your goal is to go out and attack an organization and to do some specific damage, you have all the time in the world. You can focus, you can do that, you can take the time to search, you can go out there and this scenario was great. But for defenders and for professional penetration testers, it was really kind of a nightmare, because we don't have time. We've got other business requirements. We can't spend all day out there searching through forums trying to figure out who released what exploit for this or that and how we modify it to work in our case. So what really ended up happening was our ability to determine the actual risk that's posed by a vulnerability was considerably hindered. We can say, here's a vulnerability, and we know it's here, and maybe some bad things could happen from it, but to know where it could go from there was much more difficult. And as a penetration tester, you are very limited within the scope of time you have to often exploit all the possible vulnerabilities that you may have found. So in about 2003, a young man named H.D. Moore, who I'm sure you've probably all heard of by now, he released something called the Metasploit Framework. I believe this was in October, and he posted it on a mailing list and said, "Hey, here's something I've been working on. What do you think? Here's kind of where I'm going with it." The goal, as he put in there, he said Metasploit Framework is a platform for writing, testing, and using exploit code. So he kind of was hitting all of the major issues at that time. If you were somebody who was writing exploit code, it was kind of a pain in the rear. Every time you wrote a new exploit, you had to rewrite all of the administrative stuff behind it, all of the networking modules and everything. If you wanted it to, after it does the exploit, if you want it to call back to you, you have to write all of that or have your own libraries built in, and it's really a pain. If you wanted to test your exploit on lots of different systems, again, it's really kind of a hassle to go through and do that. And then also, if you wanted to actually use those exploits, it just wasn't very easy. So with Metasploit, HD really focused on creating a standard framework, a platform that we can all use to become better as professionals, to become more efficient, and ultimately to really help us determine what our end goal is of helping determine what the risk is to the organization that's presented by vulnerabilities that we may have. One of the goals there, one of the ones that I really wanted to point out that HD has always been a big proponent of, is that Metasploit would always be free and open source, and that's something that he has held strong to. We'll come back and mention that here in a second. This initial version 1, was written in Perl, and it only had about 8 exploits, which when you first see it, you're like, 8 exploits? Wow, what's the point of that? I think there was an IIS exploit, and there was an FTP server and an SSH server. But they were pretty minimal. But what HD did a really good job of is thinking long term, and he designed out the infrastructure and the behind the scenes structure of this framework so that it would be very extensible and easy to grow. And grow it did. Over the next several years, it continued to grow. Version 2.7 became very popular. That was a really big one that was around for quite a while. It grew up to about 150 exploits, and really, that's kind of when it garnered a name. There are other commercial products out there that try to do the same type of thing as Metasploit, but Metasploit for a long time has kind of become the de facto standard. In 2007, they said, hey, we've got some problems. This is written in Perl. There's some things we can't do. It's not really easy to modify certain things. There were several different reasons, but they decided to rewrite it. A coworker of mine used to say that Perl is a write once, read never language. And I've always found that to be true. Anytime I write something in Perl, I can always figure out how to do what I need to do. But if I ever have to modify it, I'm out of luck. So he chose Ruby. I think at the time they were looking at either Python or Ruby, and Ruby won out primarily because there's some other frameworks written in Python. And being an open source project, they didn't want to have to worry about somebody always stealing their code and selling it commercially. So in 2009, just to kind of finish our brief history here, Rapid7 purchased the Metasploit framework, the trademark, and all that. That was really kind of a turning point, and kind of a questionable move at that point. Up until then, H.D. Moore had a full-time day job. He worked for another company, and he did Metasploit in the evenings. There was quite a number of contributors, a lot of people that helped out and committed updates, but the brunt of the work was HD. Anytime a new release came out, HD was the one doing the testing and making sure everything was good to go. So in 2009, when this first came out, everybody's concern was that Rapid7 would take the project, that they would shut down or just quit development on the free and open source version, and that they would commercialize it and come out with their own fork that was just not given away for free. HD really stood up, as I mentioned earlier, that he's a big proponent of free and open source software, and he one of the things he said is that it would always be free. The Metasploit, the base framework would always be available and free. So he went to work for Rapid7. He's been there now for several years. And one of the amazing things, what they've done is they have contributed so many resources, so much money and effort into the project, partly to begin their own development of some kind of offshoot commercial projects, but all built upon the free and open source version, the framework. So as you can see there, currently as of, actually that was yesterday morning, 1,286 different exploits, 783 auxiliary modules. You can see the numbers. We're going to talk about those in a little bit more detail here in a few minutes. Right now, Metasploit is the world's largest Ruby project. So that kind of says something about the number of lines of code that's in there. I saw something from a couple of years ago. I think they said 700,000 lines of code. So moving on, we've kind of talked about how the history of Metasploit, but really we want to jump in and start looking at how do we use it, what do we do with it, where do we go? So the first question is always, how do you get started? Where do you get it from? One of the easiest places is just to go to Rapid7 site and download it directly. You can download an executable that you can install on any Linux or Windows system. It does work pretty well in Windows. There's a few things that don't work perfectly. I would recommend that if you aren't comfortable enough with Linux to use it, it's a good opportunity to try it and get started. There's a lot of tutorials out there that will walk you through step by step exactly what to do for just about any module you would run. One thing to note, when you download from Rapid7, when you first go to that page, up at the top, on the top of the page, it's going to try to get you to download Metasploit Pro or Metasploit Community Edition. These are kind of point and click wrappers on top of Metasploit that Rapid7 tries to sell. That's their their reason for wanting to continue development of the Metasploit framework, is so that they can continue to sell their products that they've written on top of it. You don't have to run those. The Community Edition is free, but you don't have to have that to use the framework. If you scroll down to the bottom of the page, you can download just the framework itself. Another good option, and I probably recommend this if you're not familiar with Linux, or if you're brand new to Metasploit, I would recommend going with a live CD or a virtual machine distribution. The previous version of Samurai WTF, that's the web testing framework, in case you were wondering, has Metasploit involved, and then also Kali Linux, which is the successor to Backtrack Linux, also has it installed. In both of those cases, you might want to update it to get the latest modules and all that, but you should be able to download it. You can download the virtual machines and boot them up immediately in VMware, and you're ready to go. So talking a little bit, I kind of mentioned briefly the point and click editions. These aren't so much editions of Metasploit as kind of wrappers. You see there, Rapid7 has 3 different ones, and then there's 2 others, Armitage and Cobalt Strike. Each of these add some functionality and some ease of use features. If your primary job is a sysadmin or a network guy, and you want to use Metasploit for a few specific things, then one of these may be beneficial to you. They kind of streamline the process, especially if you don't use it all that often. And they also have some additional reporting and some compliance monitoring stuff as well. But the problem with, and the reason that I don't like to point people to these to begin with, is if you start with the point and click version, you'll have a much harder time understanding what's really happening behind the scenes. So, you'll know, okay, I click here, I click here, I click here, and this happens, but you won't really understand why that happens. So later, when you start using, branching out, using more modules, trying to do new things, and maybe even at some point, uploading your own or modifying existing stuff to work in your area, you'll have a harder time with that if you don't really understand how it's working behind the scenes. So The command line access is what I always start with, and in fact, that's what I always use. I've played with some of the Rapid7 stuff just to demo it and see how it works, but I always end up coming back to the command line just because, quite honestly, it's really easy to use. And Rapid7 has actually produced quite a good amount of documentation on each of the command line options, how to do what, and how to walk you through it. So it's really simple. Uh, there's four different, well, there's actually more than four, but these are the four primary uh, uh, commands that you'll run. msfconsole is the Metasploit console. That's primarily what you'll use. You can do everything within msfconsole. The other three, msf payload, msf encode, and msf CLI, which is the command line interface. These are three kind of one-time use um, applications. So for instance, if you're just wanting to generate a standalone payload, let's say output it as a .exe or maybe a Java jar file or a PHP file, you can use MSF payload to take a Metasploit exploit module and then output it directly into a payload that then you can copy to another machine manually via USB drive or in some other manner. MSF encode is designed as it sounds. It's designed to encode or obfuscate your exploit. This basically allows you to bypass most antivirus, IPS systems, any kind of defensive system that may recognize the exploit or the payload. MSF encode is designed with several different techniques to change the core of the exploit so it's slightly less easy to discover. And then the CLI is basically just a direct command line interface for launching pretty much anything within Metasploit. It's really designed for scripting and to be able to do just one-off things. So, but what we're going to spend our time in is the MSF console. So we're just going to jump in here. It's pretty straightforward. When you from your command prompt, I'm running in Linux here. From your command prompt, you type in msfconsole, and like any good ASCII security tool, you get some ASCII art there at the top in the form of a banner. Now I'll tell you, this is kind of a secret. This is one of the benefits you get from taking a webinar from someone like Secure Ideas. There's about 10 different banners that show up. It's all random. There's actually a script as part of the launching process that picks one of the banners at random and throws it up on the screen. So you might get the same one 3 times. You might get a different one every time. But I'll tell you, if you get the little cow that says Metasploit, for whatever reason, I can't explain. I think there's some black magic somewhere, probably some voodoo. But if you get this cow, your exploits work about 50% more often. So I always type MSF console and then exit 12 or 15 times until I get the cow, and then I'm ready to go. Or you can go and just modify that script so it only picks that one if you want to cheat. But needless to say, I like the cow. Moving on down, you'll see where it says tired of typing, set our hosts, etc. Blah blah blah. This is about as intrusive as Rapid7 gets. They throw in here when you start it just a short little, hey, here's Metasploit Pro is easier. Go here and launch it. That's pretty much all they do. Otherwise they pretty much stay out of it. But you can't fault them with as much money and resources if they've thrown into it. You can't fault them for trying to make a little money off the deal. You see the going down a little further, you've got the specific version of Metasploit, and then lists, as I showed before, the number of exploits, modules, payloads, etc. that are currently loaded. This is really interesting. So I took this picture yesterday morning, and you notice it says 698 auxiliary modules. About an hour later, so I did MSF update. MSF update is just it runs the update. It's fairly automated and pulls down everything, and it's really easy to use. But so I did MSF update. I launched it, took this screenshot, and notice it says 698 auxiliary modules. About an hour later, I accidentally typed MSF update again. I think I was hitting up, and hit enter or something on the wrong command, and it launched it again. And it came out with 782 auxiliary modules. So within that hour, somebody had committed whatever that is, 84 modules. I was pretty impressed with that. That's not common, obviously. You can tell the numbers, that doesn't scale very well. But somebody was eating their Wheaties yesterday morning when they started committing stuff. Um, so moving on, you'll notice the down at the very bottom we got the Metasploit framework prompt, which is pretty easy to recognize. So the first thing you do when you don't know what you're doing on any system, right? You type help. You will be amazed at how much this screen scrolls. There are so many options and functions and features that can be run from within Metasploit. I'm not even going to try to walk through all of them. That would take a ridiculous amount of time, and quite honestly, you can read. If you're trying to learn how to use any tool, it's worthwhile to walk through the help and just see what's available. I will tell you that some of the neat things, even though you're within the Metasploit framework prompt, you can still run most system commands. So you can still do ls, pwd, you can cat files. I'm not sure other programs. To be honest, I've never tried opening something like Emacs or VI or Nano or whatever. I don't know how that would work, but most operating system commands you can run just fine from here, in addition to the Metasploit specific commands. But instead of walking through each of those, really what we're going to jump in is we're going to jump in and exploit something and kind of figure out, okay, how do we use it? Because I found out that once you learn how to use something and you figure out something you can do, it's a lot easier to figure out something else later on your own, right? If you know how to do it the first time, all of a sudden when you go in a second time to do something slightly different, your mind starts saying, well, I did it like this last time, so maybe if I modify this, let's see what happens. That seems to be a much more productive way of learning than walking through each command, which is just quite honestly boring for both of us. So before we can do that, though, before we can exploit something, we need to talk just a little bit about some of the terminology. You've heard me use a lot of words already that I didn't really explain very well, but we'll go ahead and jump in here. So Metasploit is broken up into modules. I mentioned earlier that when HD designed this, he did it from a perspective of making it very extensible and flexible so that it could grow and stretch out and do new things that maybe wasn't intended. Everything is a module of some kind. When we talk about exploit modules take advantage of some kind of vulnerability. So, maybe it's a buffer overflow, or maybe it's a PHP remote file include, or whatever. An exploit is actually going to take advantage of that vulnerability and then allow you to do something. The payload is what actually does something. So an example of a payload might be to add a user to a system, or might be to grab the hashes off of a system, or a payload might be to set up a VNC server so that you can connect back into the system. Basically, you can think of the payload as, what do I want to do on that system once I've compromised it? Encoder modules, as we kind of mentioned before, are all about obfuscation. They're basically just designed to help you bypass malware. This is one of those areas people always kind of question, wow, why are we putting all this out there for free? Why are we making it so easy for bad guys to do this? And it kind of comes back to the conversation I had earlier, that this is already pretty easy for the bad guys to do. It just takes longer. Without Metasploit and without some of these automated tools, they can do it. They have to walk through the process, and they have to watch a few extra YouTube videos, or spend a little bit more time in the forums to figure it out. If they're not technical savvy enough to do it themselves. But the problem is, as defenders, we're the ones that don't have the time to do that. So Metasploit, even though the encoders aren't perfect, sometimes they get caught. Sometimes you have to play around and try this and then that or whatnot. They allow you as the good guy, as a penetration tester or a defender, to simulate what an attacker would be capable of, so you can determine how much business resources really need to be spent on mitigating certain vulnerabilities. The auxiliary modules, we're going to talk a little bit more in depth here towards the end of the presentation, but the idea of the auxiliary modules is it does something that's not specifically exploitative. So for instance, a scanner, some of these are discovery modules. We'll look in a little more detail on those here in a few minutes. And then you've got listeners. Effectively, they set up a network listener so that you can connect back into. That might be setting up a listener on the target system once you've compromised it, so that then you can connect into it from somewhere else. Or it might be setting up a listener on your local system, and then your payload connects back to you, kind of a reverse connection there. Meterpreter is also something that's important to know. Meterpreter is a very special payload. A lot of times when you hear people talk about Meterpreter and Metasploit, they'll kind of use them interchangeably. But Meterpreter is a very specific advanced payload that basically allows you to do more on the target once you compromise it. It's extensible and it runs in memory on the target. So once your exploit is successful, you push down Meterpreter as your payload, and it's kind of a hook in the operating system, almost kind of like a backdoor. If you're old enough, think like Sub 7 back in the day. Meterpreter lets you connect in and then do whatever else you want to do. And then it's also extensible through plugins that are listed there. You can upload plugins that allow you to do additional functionality that wasn't originally part of the core system. So moving on, let's exploit something. Here's what we're going to look at. We've got a target machine that's an unpatched Windows XP machine. I think it's actually got Service Pack 1 on it, perhaps. And we're going to use the exploit MS08067. If you're not familiar, that was a very serious vulnerability that came out in 2008. Sorry, obviously. Microsoft's naming convention, if you're not familiar, MS stands for Microsoft. 08, the first 2 digits are the year that it came out, and then -067 is the 3-digit sequential vulnerability number for that year. So obviously, when they set this up, they were pretty confident that they would never get over 1,000 vulnerabilities in a year. So far, they've held to that. Hopefully, that doesn't become a problem for them in the future. So we're going to run this exploit on this system, and then we're going to use the Meterpreter payload to show you some of the functionality and how that works. Now, one of the first questions that you should be asking is, how do we know that the system is vulnerable to MS08067? How do we know to use this exploit? Because a lot of times when people want to start using Metasploit, that's one of the first issues is, okay, what do I do? What exploit do I use? And I'm not going to go into a lot of detail on that in this webcast. That's more of an issue of how you find vulnerabilities. There's a number of ways though, so I'll just kind of walk through. First off, sometimes, if you have access to the system, either as a limited user, maybe it's like a kiosk, or maybe you're logged in as a very restricted domain user or something like that, you might be able to determine that Windows patches haven't been updated. You can also Metasploit actually has, I mentioned the auxiliary modules. There's an auxiliary module that will scan a network looking for systems that might be vulnerable to MS08067. If you're familiar with Nmap, the NSE, I just went blank. Nmap scanning engine. Does anybody remember what NSE stands for? It's the scripting engine, Nmap scripting engine. Basically, it's an extension to Nmap that lets you run scripts that can do a little bit more, kind of like plugins, or that does a little bit more than what the standard engine does by default. There is a NSE script that will allow you to search for machines on the network that are vulnerable to MS08067. And of course, you could use something like Nessus or Nexpose or Vulnerability Scanner. Obviously that's going to be a lot louder and more noisy, and throw off all kinds of alerts. If you're doing that kind of monitoring on your network. But those are all different ways that you can determine whether this is vulnerable. Moving on. So we know what module we're going to use, but how do we find it within Metasploit? Because you got to have the actual name, the exact name. That's one of the downsides of using the command line, any command line tool, is you have to know exactly what to type, right? Well, Metasploit makes it pretty easy by giving us a search function. You just type in search space and then the name. Now you do have to know the naming format, the how that's put in there. But I'll tell you, so when I started this up, I never can remember whether it's an underscore or a dash. So I typed in search and I typed in MS08-067 and it didn't come up. MS08_067 and it came up right away. So you can kind of play with it a minute if you're not familiar. It's like I always tell my mom, never be afraid to just jump in and try things and see how it works. So you'll notice we found 3 different modules there, and I'm not sure why it found the first 2. They look to be the same. I'm not sure why it found 2 instead of 1. Um, there's probably something I'm missing. But see, the first 2, you notice it says they're auxiliary scanner modules. And then the very last one down bottom, it says exploit Windows SMB MSO8067 underscore net API. So that's obviously the vulnerability we want. In this case, we need to remember or write down or copy and paste that actual exploit name. Now, there's another thing I wanted to point out, actually a couple things. You notice it shows the disclosure date, 2010-28 or 2008-10-28. So October 28th there was when this vulnerability was first discovered, and the exploit came about very quickly after that. It's also worth noting over on the far right where it says rank. This is something that Rapid7 added after they kind of took on the Metasploit project. They went through and spent a lot of time ranking and classifying every vulnerability, or I'm sorry, every exploit within the system. And the goal of doing that was to determine the actual reliability. How often does this exploit work? Because some exploits are somewhat random. You try it, and it may work 1 time out of 7. In this particular one, it works almost every time. In fact, I don't think I've ever had it not work on a system that was vulnerable. But they also took into consideration the potential impact on the system. Some exploits, there's a small chance that it could crash the system. Others have a very large chance it could crash the system. Some of them could be reused over and over and over again. Others, once they're exploited once, it won't work again until the system's rebooted. So there's a lot of different things they took into consideration. If you see great on a ranking, that means you're golden. It's going to work. I'm hesitating here. I don't think I've ever had a great ranked exploit that didn't work every time. Now, when you start getting into some of the lower ranks, that's when you need to start, being more cautious about how am I going to use this? What is it going to do? You should understand any exploit and the vulnerability before you run it. But if you've got even ranked normal, or especially if it's ranked low, there's several other rankings. I can't remember all the list, but if you've got something that's a lower quality exploit, you need to be very, very careful about it and test it extensively somewhere other than production before you decide to use it. So moving on here, there is one other way. I'm sure there's others, but one other good way to find a module, and that's just to Google it. Rapid7 has done a really good job of documenting all of the exploits that are out there. And this is just a small screenshot of the page. If you Google Metasploit MSO8067, you come up with, I think this is like the first result. Also, if you use use something like Nessus or Nexpose, Qualys, any of the vulnerability scanners, when they find a vulnerability, they're going to provide you, oftentimes they'll tell you that Metasploit has a vulnerability, and they might link directly to this page. That Metasploit has the exploit, but also they'll provide you with the CVE number so that you can go actually look up the vulnerability declaration to see what is listed, or any exploits available. And usually those pages, if you're looking somewhere like the OSVDB, the vulnerability database, or any of the vulnerability databases out there, they will link back to Rapid7's Metasploit page. And further down on this page, it actually shows the ranking as well. But so let's jump back in to our console here. So the first thing we're going to do up at the top, follow along with me, you can say we're going to use the use command, and we're going to tell it to use this exploit that we found just a few minutes ago. And you'll notice on the second line, as soon as we do that, it changes our context of our prompt. So now we're in exploit mode, and we've got our MSO8067 exploit there selected as the current context. So now the first thing I always do, no matter what, even if I've used this 1,000 times, the first thing I always do is type show options. Partly because I never know if something might change, if they might put out a new version, and I want to make sure something's available. Also because I always want to make sure that things are set correctly before I run anything. Before I actually run an exploit, I want to make sure that things haven't been modified. Maybe I was testing something or whatever, and this changes got saved. So when you type in show options, it's going to show you all the specific options for that exploit or for that module. Now, understand that this is module specific. So in this case, there's only really four things that are needed for this exploit to work. You need the remote host, which is listed as our host, and that's an IP address that you have to put in. You need the remote port, which is always going to be 445. I've never seen it be anything other than 445. Technically, it's possible, but I can't imagine that being in a production system. And then you'll also need the SMB pipe, which is always set to browser. So really on this, the only thing you really need to change is the remote host. Now, you'll also see down there at the bottom where it talks about the exploit target. If you type in show targets, it's going to show you a huge list of all the possible targets for this system. So you've got Windows XP Service Pack 1, Windows XP Service Pack 2, Windows XP Service Pack 3. It goes through all the different lists. You've got different versions of OSs with different languages. Sometimes you'll see the Spanish version and the Dutch version, etc. For most of the really popular exploits, you can leave it set to automatic targeting. Leaving it set to 0 will automatically try to determine what OS it is and then run it. Some exploits, especially if they're like more web specific, you may have to tell it, hey, this is against a Linux web server or a Windows web server, or it's Apache or IIS or something like that. And that just helps the module do whatever's necessary to correctly exploit that system. But so once we viewed the options, we know we need to set the remote host, and we do that back up at the top just by typing in set space our host space and then the IP address. And this is just an IP address of this vulnerable machine that I know I've got set up in my lab. And what you're going to see, it comes back on the second line there, showing you, confirming that it was set correctly. And then you can type show options again, and you'll see the only thing that's changed is our host is now set to the correct IP address. Moving on here. So now we need a payload. Notice we talked about the module. We got the exploit, or the exploit module, and we got that set up. But we need a payload. And there's basically three different types of payloads. And we're not going to go into a lot of details, but you need to at least be familiar with how these work. So a single payload is basically, they call them singles. It's just a simple, self-contained command. Doing something like adding a user, executing a command on the system, whatever. Those are very, very simple. A stager is something that sets up a network connection. So, if it's going to connect back to my Metasploit system, if I want the target, once it's compromised, to connect back to me, or if I want it to set up a listener on its own machine so that I can connect into it, that's what the stager is designed for. And that's separated from the actual payloads so that it doesn't have to be rewritten over and over and over again by every exploit user. It goes back to the modularized design of the system. And then with each stager, you have a stage. So you either have a single or you have a stager and a stage combination. And the stage is an advanced payload that does something more than just a simple command. It may launch a VNC server. It may launch a command shell back to you. Or as we talked about before that we're going to look at, it may install Meterpreter. So jumping on here a little bit. So what we're going to do, we've already set up our exploit. Now we're going to type, you notice at the very top, we're going to type in set payload Windows/Meterpreter/reverse_TCP. Now something I didn't mention before, this is very, very helpful, and I can't imagine living without it. Metasploit has autocomplete built in. So when I type in set payload space WI tab, it fills in Windows. I hit /MET tab, it fills in Meterpreter, etc. So now, like for instance, if when I get to the last and I type in RE tab, it's going to go to reverse and then stop, because there are several different ways you can do it other than TCP. So I type in _T tab and it fills in the rest of it. That's very useful for not just payloads, but exploits, for anything you're doing in the system, to have that autocomplete. And also, if you're not sure, if you can't remember, let's say you want a Windows payload, but you don't remember which one. If you do double tab, it'll show you all the list of available payloads in that directory that you may want to use. So anyways, it confirms that that's set up. And then, as always, I always type show options again just to make sure everything's set. This time, notice when I type in show options, I've got the module options, and then I also have the payload options. And now, so see, there's a few more things we need to set. The exit function, usually you can almost always leave that default. But we've got a local host and a local port, L host and L port down there at the bottom. Those are two things we need to set. The local host is obviously just the system that you are, because, okay, I didn't mention this before, because this is a reverse TCP payload, that means we're going to deploy Meterpreter on the target system, and then it's going to connect back to us to let us run it. That way we don't have to worry about a firewall in that system or anything like that. We're assuming it can get an outbound connection to us. So we set up the L port, which is just our local, the L host is our local IP address, and then the L port, whatever we want to use there. 4444 is the default. I always change that in a production system just because I have actually ran into places where I had a company that set up alerts. So anytime anybody tried to connect to anything on 4444, they threw up an alert because they assumed it was probably somebody using Metasploit that didn't know what they were doing or didn't know enough to change it. That's kind of questionable practice, but it made sense. Chris has questions. Should all payloads work with all exploits, or is there a way to know which map to your exploit? No, all payloads do not work with all exploits, and here's why. So this is a Windows exploit, right? That's a Windows SMB. It's a Microsoft exploit. We're using the Windows Meterpreter payload to tie to that. There's a Linux Meterpreter. There's actually a version of Meterpreter that runs in PHP or Python that let's say you have a file upload vulnerability on a web server. You can upload the PHP Meterpreter or the Python Meterpreter and then actually connect to the system that way. Now, as far as knowing which one to use, that's a little more difficult and somewhat comes with experience. The easiest thing to do to get started is start playing around with what you know, and then start watching online. There's tons of tutorials. We've posted a lot of blog posts. There's videos all over the place. I mean, you go to YouTube or Vimeo, and there's tons of videos of people showing you how to do this and how to do that. Really, the easiest way to know which one you want to use is just by experience of using it. I will say this. There was, 782 payloads out there. I've probably not used more than 10 or 12. Just because once you kind of figure out what you want to use and what you want to do, that's what you stick with. There are some very specific use cases for most of them. Of that 782, maybe 600 of them only have one specific use case that you would ever want to use that. And if you don't know what it is, you don't need it, kind of thing. But in the beginning, to get started, you'll really only end up using 3 or 4 different payloads to kind of do what you want to do. So after we set the L host and the L port, moving on, the next command, we type exploit. You can actually type run. It used to be exploit. That's what I've always done, just because it sounds cooler, I guess. I don't know. But what you can kind of follow along there. It'll start following through, and it'll say it's starting the reverse handler. It'll automatically detect the target, so it determines by fingerprint that, okay, this is a Windows XP service pack 0 or 1 in English. Attempting to trigger the vulnerability. Notice it's sending this. Okay, so after it attempts to trigger the vulnerability, that means it's done the exploit. Now we're going to send the stager. So the stager is done. Now we're going to send the stage, and so it shows the number of bytes. And one of the most beautiful things you can see is Meterpreter session 1 opened. That means we have compromised that system. We have access to run commands on that system. Now, depending on the exploit, we may or may not know what level of user we have on that system. We may be a limited user so we're not really root yet, but we've at least got that first level onto the system. There's a lot of things, even if you don't have root access or administrative access, there's still a lot of things you can do on the system, and a number of ways that you can use privilege escalation vulnerabilities to raise your privileges. So moving on here, I want to talk just a little bit about Meterpreter, kind of how it works. So Meterpreter, as I mentioned before, it runs in memory. It doesn't write anything to the system itself, which also makes it much more difficult for some defenses to catch it. Now, I will tell you, by default, so if you just deploy Meterpreter like this, most of the time, most antiviruses aren't going to catch it. If you were to take, like we talked about earlier with MSF Payload, you can build a custom standalone exploit that includes the Meterpreter payload in it. If you take that and go try to run that on a system with pretty much any antivirus, it'll detect it right away. So that's where you get into using something like MSF encode to modify and kind of mangle the exploit so that it still works, but it's not as obvious for AV to detect. Now with Meterpreter, once you get it launched, once we get that Meterpreter prompt, there's a lot of different things you can do. Obviously, the first is type help, because that'll walk you through and show you, just like with Metasploit, Meterpreter has its own set of functions and features that you can do. Um, it's also worth noting that you can run most OS commands, maybe not most, you can run a lot of OS commands from the Meterpreter prompt, and it will run on the target machine. So for instance, if you type in PWD, it's going to show you the path that you're in on the compromised machine. If you type in CD or LS, it'll do what you expect. Now it's interesting because we've compromised a Windows machine, but we can still type in LS, and Meterpreter does the magic in the background to translate that to DIR and run it on the machine, and then shows you the results. There's also a lot of networking stuff you can run. You can type in ARP, and it'll show you the ARP table from the machine. You can look at the IP addresses, the netstat. You can actually even do port forwards and routing through that machine. So once you have Meterpreter on a network, you can use that Meterpreter session to target other attacks through that machine onto other machines that you maybe not have previously had access to. So there's some really cool stuff you can do. That's kind of outside the range of this talk here. You can also upload and download files. That's kind of finicky sometimes. I'm reluctant to use that unless I just have to, because sometimes the upload and download doesn't always work quite like you would expect. Things get held up or crash or whatever, and you have to relaunch the exploit to get your session again. And then there's several other things: recording keystrokes, screenshots, webcams, microphones. A lot of neat kind of fun stuff you can do for demonstration purposes. Usually, other than the keystrokes, most of that stuff doesn't have practical value in most penetration tests, but it is nice to be able to show people what's possible. And then there's several additional plugins. I'll just kind of walk through those here in just a second. So to use Meterpreter, you just type in a command. One of the commands, sysinfo, shows you some information about it. As I mentioned, it's a Windows XP machine, Service Pack 1. It's a 32-bit machine. If I type in get PID, that's going to show me the current process ID that Meterpreter is running in. Remember, so I said the Meterpreter runs in memory. Well, what it's doing is running in the memory of the service that was compromised. So in this case, it was the SVC host service that runs the server service that got compromised. So we're in process ID 984. And then if you type in get UID, that'll show you the current username. In this case, we're running as system, which is great. If you were to compromise, let's say you exploited a vulnerability in Apache, and Apache is running as a limited user. Well, you type in get UID, and it's going to show you the username of whatever Apache is running as, because that is the memory that you're currently running as. So at that point, what you need to figure out how to do is, how do I get to a higher level of privileges? There's a couple of ways to do that. There's actually a function, I don't have it shown here, but there's a function called, or a command called get system, which runs through like 6 or 7 different common privilege escalation attacks and tries to get you to a system level set of privileges. Another thing you can do is migrate. So for instance, if you type in PS, it'll show you a list of all the processes on that machine. And if you're running in one service, maybe it tends to be buggy, or maybe it's likely that somebody may stop it. Maybe you've compromised like Chrome or Internet Explorer, and you think that they might close that browser before long. You can migrate into another process that's running on the system, so that you're less likely to be shut down. And there's a lot of other things you can do. I'm not going to walk in detail. Obviously, we don't have time to go into too much detail on all the different functionality. But if you walk through the help files, you can type in shell, and it will give you, in this case, it would be like a Windows CMD shell prompt that then you can run anything that you would have otherwise run on the machine. And then you can also, there's a default functionality called hash dump that dumps the contents of the SAM database. So you have the usernames and the password hashes that then you can take and try to crack or use for pass the hash attacks. Moving on here quickly, I know we're kind of getting low on time. There's several additional plugins you can run. Mimikatz is a really nice one. If you're not familiar with the Mimikatz tool that was released a couple of years ago, it basically grabs passwords and password hashes out of memory. So that was converted into a Metasploit module. Now you can load Mimikatz. Now when we type help, it'll show all the additional help along with the Mimikatz commands at the bottom. At this point, if I type in, say, Kerberos here, it's going to dump out the plain text usernames and passwords of any processes that are running on that system. So whoever's logged in, and then also if you have a service running as an administrative user, it's going to show me the password for that system as well because it's taking it directly out of memory. Now there's there's some other modules that are really nice, or plugins, I'm sorry, that are useful. There's one called Incognito, which allows you to steal and manipulate authorization tokens, being able to pass tokens back and forth, and kind of similar to pass the hash, but a slightly different attack. There's a plugin called LAN Attacks that allows you to set up a DHCP server. There's one called Sniffer that allows you to do a packet capture. Several others that are just really neat and fun to play with that may address whatever your need might be. So moving on to the auxiliary modules that I mentioned earlier. Rapid7 defines an auxiliary module as an exploit without a payload. This is basically something that runs and does something, but doesn't actually do anything on the system itself. I think that's kind of I don't know, I don't like that explanation, but we'll go with it. So as I mentioned before, there's currently, as of yesterday morning, 782 auxiliary modules. And these basically do one of three things. They're either for sniffing and trying to find, capture something that's going across the wire. They're for scanning a system and looking for certain criteria, or they're for fuzzing and trying to throw something into a field and get a response, see what it gets. Some examples of these, Tomcat Manager login. What that does is that scans a network or the IP range you give it, and it looks for default usernames and passwords on Tomcat Managers. I think it'll actually show you if it finds the manager login page at all, but it'll also try the default password, and it'll tell you, okay, here's ones that have default passwords. That's obviously a great step towards getting compromising that box. DIR listing looks for web servers with directory listing enabled by I don't remember exactly how that works. It basically finds if directory listing is enabled by default on that web server, not on the specific individual pages. VNC none-auth basically looks for VNC servers that don't have any authentication, and there's some others. msSQL exec, that's a neat one. That looks if you have credentials for anything, any credentials you may have, you can put those in a file. msSQL exec will use those credentials and try to log into msSQL servers and find some that have the stored procedure XP command shell available, so that then you can actually compromise that machine by using the credentials on Microsoft SQL. So there are several additional non-attack type uses that you can use Metasploit for. And these are generally focused on discovery, fingerprinting, automation. And I just kind of listed a few of these here. So for instance, scanner SSH version, that will go through, you give it a range of IP addresses, and it will find every SSH server that's listening and specifically what version it is running. So, if you're a sysadmin or a network admin guy, that could be really useful to go through and find out, okay, what do we actually have on the network? You can use Nmap, you can do some of that. There's some other tools. You could use something like Nessus that's going to be really noisy and loud. But this is a very simple and straightforward way to do that. Same with msSQL login. You can find SQL servers that are out there that have login connections and whether default passwords work for them. The IPMI, this was a neat one. I actually used this just a couple weeks ago on site with a client. They had, we were doing some vulnerability scans, and they came up with a whole bunch of baseboard management consoles that were connected to the network that they didn't even know were connected, and most of them had default passwords, which that will allow you to basically compromise that machine from underneath the operating system. A lot of times people miss out on that vector completely. So with IPMI, we were talking about this, and one of their sysadmins didn't know how to find it, because I mean, they can do an nmap scan, and nmap's going to show, okay, here's the web servers that are available. You can scan on certain ports, but they were getting a lot of false positives, and it was going to be a lot of information for them to sort through. So we pulled up Metasploit, and I showed them how to run this IPMI version module, and it basically comes back and lists every IPMI system that was listening, and that then at that point they could go connect to. And it also by default shows whether or not the default usernames and credentials are available on those systems. So some other ones there, SNMP login is a good one to find. It uses kind of standard default community strings to find out if you've got network devices listening with default community strings for SNMP. So kind of giving you an idea of what you can do with Metasploit and why, even if you're not a pen tester, what some of the advantages are of it. The next step where you go from here is to really set up a lab and start playing with it yourself. As I meant, I always hate when people say, oh, I don't know how to use this, or I don't know how to use that. And I say, well, what have you tried? Well, I haven't gotten around to trying it yet. Well, until you try something, you'll never figure it out. So what I always recommend people is, if you can set up some virtual machines, that would be great. If you have to set up, some old actual individual machines, that works too. But set up some different operating systems, some different vulnerable systems, so that you kind of know what's there, what exploits are available. Install Metasploit or load it up with a virtual machine and get running, banging on it. The guys over at Offensive Security also have an awesome training. It's called Metasploit Unleashed. They do a pretty good job of updating it. It's not updated as of with yesterday's updates, but it does a really good job of walking you through step by step how to use Metasploit and how to use every individual feature, even to the point of starting to develop your own exploits and all that kind of stuff. It's completely freely available. They do encourage you, if you find it useful, to donate to Hackers for Charity to help out there. And then I highly recommend the book if you're planning on doing much with Metasploit at all. There's a book called Metasploit: The Penetration Tester's Guide, and it's by David Kennedy and like 3 or 4 other guys. It's about $30 on Amazon, and the problem is you won't find it used. I'm a big fan of buying used books on Amazon, but this one nobody wants to get rid of. It is the best book out there. It's a few years old now, but it's still fabulous. So I strongly recommend that if you plan on doing very much. Beyond that, I had a shop teacher in high school that always said, measure twice, cut once. Measure twice, cut once. That was his big thing. It's always important before you do anything in production system to make sure you practice and you know what's going to happen and how it works. And then also, if you're doing this in any kind of work environment, always make sure you have permission and get permission from somebody who has the authority to give you permission. You don't want to be standing there with a get out of jail free card and then find out that your boss that gave it to you didn't have authority to give it to you, kind of thing. I put on there, no one looks good in an orange jumpsuit. I will make one caveat to that. Vanessa Hudgens looks all right in an orange jumpsuit. I'll let you Google that if you want. So with that, that's kind of concludes. We get pretty close to an hour on our introduction to Metasploit. There's my contact information if you want. If you ever have any questions or anything comes up, feel free to reach out to us. We really make an effort at Secure Ideas to focus on user training and our customer training. So if you have anything that we can help with, or you just need some feedback on something, by all means, let us know, and we'd love to work with you. Are there any questions, or does anybody have anything else before we finish up? All right. Well, I'm not seeing anything right off the bat. Somebody's probably typing furiously, hoping. There we go. Are you going to do any more of these free talks? Yes, we do plan on. We're kind of in the works. This quarter, we've started ramping up with a goal of eventually getting to where we do 2 or 3 talks a week. I don't know if we'll ever get there or not, but we'll definitely be doing some more of them. At least probably, I think right now, like every other week or so. If you go to secureideas.com and then up at the top, click on events, you'll see our events calendar. And we've been shooting for Thursdays just because that seems to work with everybody. Seems to be a pretty good time to do it. But yeah, if there's specific topics that you would like us to cover, shoot us an email. And otherwise, just check that out, that events page, and look for more.